Well, it's Saturday morning. We also have to wake up. Yeah. So thanks everybody for being here. As Agnieszka introduced us, we are Enrique and Nick, and we are going to talk today about secure development with Android. How many people here has dealt with security topics in the past on Android? Okay.
How many people have been hacked before? Yeah, sure.
Come on, don't be silent. Okay, that's
all right.
Good. So this is the my ego slide. My name is Enrique. I'm an IT consultant. I'm part of the Google Developer Expert crew. And this is my Twitter, if you want to follow me there. We will upload later the source code we will use. We will upload the slides. And if you have at any time any question or anything you want to talk about, you just can ping us on Twitter, and we will engage in conversation with you guys. Back to you, Nick.
Oh yeah, so this is me. My name's Nick. I live in Germany, but I'm from Australia. I work at a company called Sixt in Germany, who are actually hiring at the moment. So if any of you guys feel like moving to Germany, yeah, come on over. Yeah, and that's my Twitter, but I'm not very egotistical, so I don't really have anything else to put on this.
Good. Yep, so this is our agenda for the talk today. We want to talk about three main topics, or four if you consider obfuscation separate from reverse engineering. So our first topic, Nick will introduce, will be security network communications. The second one will be file storage. How can we store information in a secure way in Android? Which risks do we have? We will show also some demo. We think it's always better to show some code and some practical demo, because if not, people sleep. Even us as speakers can sleep if we are not doing something practical. And last, we will show how an application can be reverse engineered. That means obtaining the source code from the binary file, and how can we prevent this by using obfuscation.
Okay, should we swap mics or? Yeah. All right. Yo. All right. You want to take this one? Okay, so how many people here have heard of or have used Chuck or Charles? Yeah? That's promising. It's crazy how many places I go and nobody has ever used it before. They're using Postman, or Postman's also good, but Charles, or if you're using Windows, Fiddler, and if you're using Linux, there's another one, an open source one that actually works on all of them. An HTTP proxy is also really amazing for testing your backends. So if your backend guys are telling you that they're sending you something, but you're not receiving it properly, or you're sending them something different, then it's a really good tool for working that stuff out. Also for simulating dodgy connections. If you've got if your users are complaining about your app working badly over a 3G connection, you can also simulate that. And it also works with SSL, so you can, and that's what I'm going to show you now. So basically what I'm going to do is simulate what they call a man-in-the-middle attack. So here we have Charles, faithful program, and we also have a little program that we've created here called SnapHack. Really simple interface. All we're going to do is send a username and password to authenticate back to a web service that me and Enrique have put up. Really simple. Just send a username and password and receive a key back, which we're going to use for file encryption later on. Now, in order to do that, we have to set up our little Genymotion emulator here to send its traffic through Charles and then into the server. So essentially, we are going to simulate a man-in-the-middle attack. Generally, this would be done with some sort of DNS spoofing or ARP cache poisoning routine. But to do it on here, we're just going to attempt to change the proxy. So you go into your Wi-Fi settings. Hell. Where's the Genymotion guys? Are you here? Right, now we've got to set up a proxy. Now, the proxy is going to be my local machine here. So we need to find out what our IP is. And we prayed to the demo gods this morning to make sure this would work. So hopefully they're feeling kind. So Charles is listening on port 888, 88888. So now when I press save, all of our traffic is going to be routed through Charles. So let's log in without further ado. Now, the website, the web service that we've created is unsecure, so we're not using SSL. So don't try this at home. And we're using a very secure password. So now you can see here, hopefully you can see. It's a little bit, apologize for that. But basically in here, so you can see the request, it's a post request. You can see that it's HTTP, unsecure. And lo and behold, you can see my password in clear text, right? So all we had to do was route our traffic through a different server, and that server is now able to read both the request and response. This is why we use SSL. So what I'm going to do, that's nice and simple, but what I'm going to do is now use our a German app and not really hack it, but just monitor it. So what I'm going to do is try to log in with it. And I don't actually have a password for that, but what we can do is have a look at that request. So you can see that this request is in using SSL. And it's encrypted. So Charles is actually reading the request and the response, but it's not acting as a man in the middle. It's just passing the data straight back and forth and having a look at it, but it can't encrypt it. It can't decrypt it, sorry. So what we need to do is tell Charles to pretend to be this website, and Charles will then, to the app, it will look like it is that website, that web service, and then it will replay that message on to the real web service. To do that, we need to enable SSL proxying. So now we are activating the man in the middle attack, but the client has noticed that the SSL handshake is unknown. So it doesn't know Charles's certificate, doesn't trust it. So it's failed on the client side. So what we need to do now is, stop tweeting me, man. What we need to do is to explicitly tell our device to trust Charles. And basically, Charles has a little built-in website that will deliver its certificate to the device. And by pressing OK, we're now explicitly telling our device to trust Charles. So now, if we go to the DB Navigator and try again, and log in. Okay. Now you can see the request in clear text. So you can see the password, the username, and more importantly, the response, which is, okay, I don't actually have an account with DB-Barn, but if I did, you'd be able to see the response there. So that's a man-in-the-middle attack done very, very quickly. Happy to go into more detail with that afterwards. But what I'm going to do now is quickly show you some encryption techniques. So some of you may have heard about WhatsApp, how WhatsApp got hacked not so long ago. Anyone hear about that? Good. They were keeping their database on external storage, and other apps were able to grab their database and upload it to their servers and do whatever they wanted with it. So get external storage, like I was saying here, it's kind of like parking your car on the street. So if you're putting your files in external storage, you can think about parking on the street. You should be locking it with your keys, and then keeping your keys in your pocket, right? All apps can access what's on the street, but they generally can't get into the internal storage. Rooted phones and emulators can still get into your internal storage space, but external storage space, just about everything I put on there I encrypt as a general rule. And in this little app that we've written here, we're using Facebook's Conceal SDK. It's very simple. It's very secure, straight out of the box. Very simple interface. Has a very small payload, and there's its GitHub account. There's other ones as well, like IO Cipher and SQL Cipher, which will encrypt the entire database. So it's pretty much like having a file system, and if you look in the external storage, it's just a blob, and your entire file system is completely encrypted. So let's do a really quick demonstration of this, and I really hope Genymotion is working today. Let's try this. Okay, so what I'm going to do is just take some photos and see what they deliver. So if I take a photo, just a normal photo, not encrypted, very public.
Is this going to be public?
It's going to be public.
Fuck.
Yeah. Yeah, maybe we should have made that private. Okay, so that's a public one. And you can see, if you look into the file system, got a little folder here called SnapHack, and there's our photo there. Now, let's take an encrypted photo. And I'm encrypting this using the key that comes back from our web server. Grr. Hey, beautiful. Okay, this is going to be private, so we can do whatever we want here. Right. Oh, that is creepy. Okay, this one's private. So, what we've got here is the two photos. Now let's take these off the SD card. So the SD card can be removed at any time by the user, but also you can get into it using the device monitor. Save it to the desktop, and where is my desktop? Okay, so you can see here the public photo, completely public, and then the encrypted one, you can't get into it, right? Also, so if you log in with, let's log in and say Ricky. All right, he can see my public one, but not the encrypted ones. So that's a really quick demo on encrypting things that go into your external storage. Very quick to do that. Very simple, 1 or 2 lines of code and maybe 3 or 4 lines to set it up. But the most important thing is where you store your keys and how you get your keys. And that's where I hand you over to Richard.
Thank you. Hello, hello.
Hello.
Hello. Now it's working. Okay, second part of the talk. Now we're going to talk about reverse engineer the application. How many of you have reverse engineered an application before? Oh, that's a good number. Maybe I should choose another topic and change my presentation on real time. Now let's gonna make it. It's always good to show some demos and something's working. So yeah, reverse engineering, as you know, is obtaining the source code from a compiled binary. So when we compile from Android, we generate an APK that is binary, and the code has been it has a backsmile format, so we should not be able to access it. Why do we use Java? Java it's a language with just a very few instructions, and the opcodes and the instruction codes are fixed. That means they cannot be extended. They are defined by the language, and it's while when we know them, it's quite easy to be able to move from the code that has been compiled into the source code. And there is no real protection against that. So when the application has been transformed, we have the bytecode in Java or the backsmiley file, the text files in Android, and there is no extra security measure to uncompile it. Why Android? So one reason would be because this is the droidcon. And another reason would be also because the APKs are super easy to download. If we can access them through from the Google Play Store, we can get them from a device. Obfuscation is not really happening by default. Another question, how many people here is using ProGuard? Okay, same on the people who's not putting the hand up. And yeah, but this is not happening by default, as you know. You need to activate this. You need to say that I want to use ProGuard. So many people, if they're in trouble because you need to leave some libraries outside, they forget about ProGuard. And the translation from APK to a jar file. A jar file is really easy to read. It's a very easy process. There are some legal issues things here. As a matter of as a summary, we cannot decompile an application, recompile it, and pass it off as if it would be our own application. We cannot try to sell an application even if it would be our own one. If the license agreement, these things that we always click yes without reading it, says that we cannot decompile the application, we are not allowed to decompile the application because we are accepting the terms of usage of the application. And we should not decompile an application to remove protection mechanisms. So as a summary, it's okay to decompile an application if we want to understand interoperability, if we want to see how the application is working, if we want to interface with the application or the system, and we cannot do that to make profit of the application. That means create a copy and sell the application. There could be several purposes. So this is a list of the bad things we can do when we reverse engineer the application. We can make code injection. There was an example of a guy that took the Swift keyboard, this very cool keyboard for Android, and he injected a keylogger. So every time the people were typing things, the keylogger was sending this information to a web service. This guy made this as a proof of concept. And in the website, we could see, like, for each telephone number where the people was writing. As you could see, people can write passwords, can write credit cards. So that leads to the other point. We cannot download from obscure sources. A person could say, like, okay, I'm going to take the Swift keyboard. I will upload it for free to a website. And when you download it for free, everything you're typing is being sent to another server. And yeah, we can make some privacy leaks, like checking passwords if they are being stored. For example, Facebook is saving the cookie for authentication in the inside the application. So if we reverse engineering, we can see where it's being stored. In a root device, we could take this cookie, put it in a browser, and then being able to take the identity of another person. And of course, a classic, to cheat. So many people use it to cheat in video games, score manipulation, asset manipulations, having more lives, etc. There is, of course, a bright side, and it's a very powerful educational tool. We can learn how the big companies are working, which frameworks do they use, how do they program. We can do it to research bugs. It's much easier to make it when we go into the code rather than just having the APK. We can interface with programs if we want to know which functions they're using and how can we communicate with them. And of course, we can do it to check our own mistakes. So if we have an application that we have ProGuarded or not ProGuarded, we can decompile it, see exactly what we can see. We can try to hack it, see if we can access any web service, etc. How to obtain APKs? There are 4 easy methods I can tell here. We can pull it from the device. If the device is root, it's just as easy as calling the ADB command and getting the APK. We can use the Google Play Python API. It's basically an API where we authenticate, we put our data, and we just say, download this package for me. There are alternative sources. If we Google for download APK, there are tons of websites that are doing that. And we can sniffer the transfer of from a device. If we connect our phone to a network and we use something like Warsark, when the APK is being downloaded, we can just read it. And some ways to protect us against reverse engineering. We can write 2 versions of the application, one that is full, another one that is not full. In one there is full functionality, in the other one there is not. We can obfuscate. I like this sentence here. When obfuscation is allowed, only allows blah, 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 blah. So obfuscating pretty much takes the code and makes it unreadable for an attacker. It also makes a lot of optimizations in the code. So it's removing the code that we are not using. Sometimes it can like even improve iterations, like while iterations and everything. Another way will be to use web services. Sometimes we really put a lot of logic into the application, and an application should have only a presentation logic, so it should be consuming data and dealing with it and presenting it on a understandable way to the user, but we do not need to do absolutely everything on the app. We can fingerprint our code, which is not really a protection, but more a way to mark our code. If we fingerprint and then there is some legal issue, we can always say like, hey, but this is my code. Look what I wrote here. There is this function that I'm using to prove that this is my application. And we can use also native methods to store strings. Has many people here worked with NDKey? Okay. So NDKey, as you know, is this framework that we can use to program with C++, and it compiles into C++ native objects. So in principle, we can put there a lot of functionality that will not be reverse engineered when we are reverse engineering our application. So let's gonna sort some demo. I have here a Kraków. So a Kraków is an application that well, I was doing some demos before, so this should not be here. Yeah, this is one of those applications like Photoshop, right? We need to enter a name or a company name, then a serial, and we then need to check if this is working. So here it says bad boy because it's not the password or the serial number it requires. And if we can, for example, convert this Kraków into a jar file, we can do that with dex to jar. I have already opened it here. It's readable, probably not, but I think I can make it bigger. Yeah. Okay, so we see here that after transforming it, we can access to the code here. The code is not very readable, right? This is still the translation is not perfect. That means that the code is not compiling. There are still like some weird things you see here, like why there is here, for example, let me game. Okay, that was, yeah, that's the text to jar exactly. So here we see, for example, that we have a value of, and there is like this hexadecimal number here. Then we have like integers in find view by ID, etc. But more or less, we can see that this is native. This is Android code. If we have been programming with Android, we know that this is an activity. There are some buttons, etc. And this is the Kraków itself. This is the logic. We can see here that we are taking a string. There is like here we are taking the string from two views and working with them, dealing with them, taking some substrings. I have so this is a process that takes some time, right? Until we can like exactly see what the code is doing. I have taken that, done that job for you, and organize everything in a way that it compiles. So I'm gonna start the application here, debugging, so we can see exactly what it is doing. Basically, this code is taking our phone number of the device, is taking some digits, then it's taking the device ID and the serial number. It's also taking like the first 4 digits. It's making some base operations between them to combine them. And okay, I hope it's working. So I downloaded Android Studio 2 last week, and I thought that the failing during demos, it was a feature of Android Studio 1.5, but it happens also of Android Studio 2. It must be something inside Android Studio. Okay, so yeah, I'm here. I'm debugging the application. And if I can here, I can say that I can see that if the string, if there is this condition fulfilled, then I will show a message showing good boy. In a real application, instead of showing a message, I will probably activate the license. I might allow the users to have more access to another features, etc.
It says God boy.
Good boy. God boy, yeah. Like
even better than good.
Yeah, so if you are God boy, it allows you to use the application. If it's good boy, it does nothing. So God is a good one. And as we see here, this is the string we are creating, is or the string that it should accept is 504237, blah, blah, blah. I have already copied it here. So if I came, I'm going to finish the execution of this application. Good. So if I came here back to the Kraków, and for example, I use here as the first seed this string from here, right? So this is the one I'm using as a name. And I'm going to enter this serial. Right, so code boy here. I cracked the application. But you can see if I type a 1, bad boy. So it's Yeah. Yeah. And as you see, this is really, if we are not using ProGuard, it's something like really immediate to come and see the code. However, if we are using ProGuard, I have here one application I just decompile and open in GDG. So this is a Java decompiler. It pretty much open any jar file and so as the insights. Here we can see that we have a package called Crassalytics. Does anybody know Crassalytics? Yeah. I hope there are no representatives here, so we don't get a demand for reverse engineering the application live. But they make it right. You can see here that there are a lot of classes like A, B. It's which person will name their classes like A, B, C, and having variables called A. That's like a really bad programming practice. But no, that's done by ProGuard. So ProGuard changes all the names. ProGuard can make interlacing of functions. So if we have one class, ProGuard can separate this class into two different ones. It can reference one from the other. It makes a lot of code optimization. It sometimes even create unreachable and unusable code, which might take a little bit more of a space, but it's really useful to confuse an attacker, which is trying to see what we are doing. So that would be one of the lessons of today. If you're not using ProGuard, start doing it now, because you can see your application can be decompiled in seconds, and ProGuard makes this work much harder. So back to the presentation. Well, I think our time is running out. We love feedback. There is this address here. If you open it, will be a formula. We would love if you could leave some of your comments there about what do you think about the talk. We will give one book that I wrote and Nick reviewed intensively, 100 questions and answers to help you land your dream Android job, to one of the entries in the formula, and we will upload our code to this repository here in GitHub. We will put it anyway later in Twitter, so you can also access it. Okay, so yeah, thanks everybody, and if you're gonna talk later, just came to us, and we will be glad to talk with you.
Later.